So we're talking about Ohm's law. This is in section 13.4. We are going over this in several stages. You've already read the chapter, and now we're actually going to do some calculations. So first of all, let's remind ourselves, what are the three things we're talking about? We're talking about um, voltage, which uh, the units for that are volts. And then we also have current. Um, Now notice the actual letter that this is stands for is I. Current is I. Um, don't ask. Um, so that one is in amps. Okay. So here we have the current. Here we have voltage. Okay. And then lastly, we have resistance, R. Uh, which is measured in ohms. Okay, so just as a reminder as well, the voltage, remember, is there's some sort of power source that has a voltage. That is what causes the current to flow. So it's the power, it's the energy source, the positive and negative charge electrically that causes the electrons to flow, which we represent as a positive charge flowing in the opposite direction of the flow of electrons. But remember, this is the source of the flow of the current. Then the current itself, current is a very easy concept to remember because you can just think of a river. The current carries the water particles through it, and uh, and we can talk about current in terms of kind of the speed, or maybe we could count the number of water particles flowing past us to determine the speed. That's an idea of the current. So you can determine both. You can determine how fast the current is flowing, essentially, and also how many electrons are flowing through a given part of the circuit at a given time. That is the current labeled with the letter I, and the units are amps. Resistance is a hard one to come up with an analogy for. It's kind of like the obstacles that the electrons have to go through because it deals mainly with slowing down the current. And this is extremely useful, and any sort of electronics that accomplish anything useful, um, the useful part of it involves resistance. So, with a light bulb, the actual filament that gives off the light um, is the resistance of the circuit. The main resistance of the circuit in that case is the light bulb, the thing actually doing something with the electricity. Without any sort of meaningful resistance in the circuit, essentially what you're doing is you're just connecting the ends of the battery, like in the previous video um, that I showed you guys with the guy playing around on the cool web app, where you're just shorting out the battery. You're just causing all the electrons that have collected on one side to flow rapidly through the circuit to the other side, which is known as a short circuit. So just like with lightning, if with a short circuit with no real resistance, all you're doing is you're having the lightning just zap down from the cloud to the ground, and maybe that sets something on fire, maybe it doesn't, but that's all you've accomplished is the electrons have moved from place to place. Um, any sort of electronics where we're actually doing anything meaningful, like electronic dishwasher or electronic oven or stove or something like that, you have some sort of resistance, whether it's the the coils in on an electric stove that as you run electricity through them, they resist, and that causes heat, and that heats your stove so you can cook things on it. I mean, the resistance is the interesting part, um, and it's measured in ohms. And the ohms have let's go over the actual letters that each of these have. So ohms, they have the special Greek letter omega for O, ohms, and amps have just the letter A. Volts have the letter V. So that's all fairly standard. But how are we going to remember this Ohm's law? Well, there are multiple ways to remember this. One of which is if you just remember this part and you do your algebra, you can do any of the following things. So how can you remember this? Well, think of a car near a cliff, maybe on a mountain path or something, and it's going around really sharp curves, and it's having to veer from one side to the other. Veer. Think of the word veer, V-E-E-R, uh, and change the E-E to an I, because that's the sound it's making. Veer. V equals I-R. V equals I-R. V equals I-R. All right, that's about as good as I can get for the actually remembering those letters in that order. But let's think of another analogy. So let's say you have remember voltage is power. So let's think of if you're trying to determine something's power, you you do it by, let's say, the current is how well something is flowing through it. So maybe let's call that flow in red. The flow of something times how hard it is to flow. So the difficulty level. Okay, so maybe instead of flow, we could even say like success or something like that. Okay, so um, if you think of you're trying to successfully have electrons flow, um, how powerful something is, well, let's say how powerful a battery is how successfully it gets things to flow, times how hard it is to get the electrons to flow. I feel like this is a useful way to remember things. This is how the car veers. All right, let's actually get to some calculations, but first we need to look at the pyramid that the guy drew in the last video. Okay, so I do want to see this somewhere in your notes, especially because this is a very useful pyramid that you saw in the last video. What this is saying is you can rearrange this one formula, which you absolutely must have in your notes. This one formula, here's all the algebra. It's been done for you. So if you, there are three different ways to write this, and here they are. So here's the regular Ohm's law as it's usually written. Remember, your car veers. But there are two other versions that are slightly harder to remember, and it's just easier to not have any fractions. Life is always easier without fractions. So there are three ways of writing this, but what I want you to focus on is the main one, and then doing algebra. But the pyramid is a really excellent way to check your algebra and do it for you. So let's get to some actual numerical examples. Okay, let's say we have 3 volts in a circuit and 5 omegas. What are the omegas again? They're ohms. And we want to know, well, what do we want to know first of all? What's missing? So let's first maybe color code these. This would be the voltage. This is in volts. This is in ohms. So ohms would be resistance. And so what we're missing is the amps. Or, in other words, the current. So we're missing the current, and I'm just going to write ohms here. This is ohms of resistance, you could say. Okay, and amps of current and volts of voltage is kind of a silly way to say things. Okay, how do you set this up? Well, remember amps. Amps are current, ohms are resistance, and volts are voltage. So remember, we say V equals IR, Vir. If we know what the voltage is, it's 3. And we know, what else do we know? We only know the resistance, which is 5. Then what we don't know is the current, which is going to stay a variable for now because that's what we're going to solve for. So this is what I was saying about some algebra involved. Now, you can see from this what we have is 3 equals I, or let's, X in algebra is often the letter you use, but in this case it's I, something we don't know. It's a number though. And it's multiplied by 5, so 5I. Okay, so just as a, remember, 5 times I. We can write these in either order because it's a multiplication. So what do we have to do to solve for I? Well, 3 is equal to 5 times something, so we divide both sides by 5. And there we have it. The current is 3 divided by 5. And so that is, remember, in amps. 3/5 amps is our final answer. Okay? Another example. But before I show you that example, remember what we're trying to do, or how we can use this circle, is if we know we're trying to find the current, then we just do volts, which is 3, over resistance, which is 5, and there we have our 3/5, okay? So I'm going to go through another example, but I'm just showing you there's either algebra involved or use the triangle. Okay, here's another almost identical example. Where it says the voltage is 6 volts, kind of redundant, but this is not an equation. This is saying V is 6 and the units is volts. Resistance is 5.5 ohms. What is the current? Again, we either do some algebra, plugging that into here, or we say, well, the current is the voltage, or 6, over the resistance, which is 5.5, and then it's in amps because that's the unit for current. And then we should probably get maybe a decimal for this or something. We should plug this into our calculator. All right, here's a slightly different one. What if we want to know the voltage, and we know that the resistance is 12 ohms and the current is 3/4 amps? Well, Vir, if we can always use Vir, VIR. So the voltage is equal to the current times the resistance, which in this case is 12 times 3/4. In other words, the 4 cancels. 1/4 of 12 is 3, and so we get 9. And the units for volts, for voltage, is volts. So this is a 9-volt battery across 12 ohms of resistance, and there's 3/4 of an amp of current. So there we have another example. All right, you should now be able to do part B of 13.4, number 3, talking about a 12-volt battery and 125 ohms. That should be enough to help you do that problem. All right.